Can you see my screen, guys?
Yes, Vasant.
Okay, thank you. Thank you. Yeah, we'll start in another 1 minute. Uh, and I'm recording this session for the subscribers as well. So just to let you know, and let me know if you have any concerns. Yeah, I think we have reached the time. Thanks everyone for joining. And before we start the session, so this is me, Yosin Shanmugam, and I'm the one who posts video on Little's Law YouTube channel. And you must have been watching it, the various videos on Load Runner, NeoLoad, JMeter, DevOps, Git, SRE, so whatever the technologies which I was working. So yeah, it's a quick introduction about me. And okay, so today what we're going to see is in this video, so we're going to see about the performance engineering. So you might ask me like, what is the difference between performance testing and performance engineering, and why should I learn this, or why should I uh, understand? I mean, like, why should I understand these concepts, right? So the thing is here is, let's say for an example, just consider yourself as an application, and when you get a fever, right? So when you get a fever or when you get some body ache or something, so your body is an application, and the fever is something like a performance bottleneck. So when we do performance testing, what we observe is we find the symptoms of the fevers. For example, like the fever actually is a symptom, right? So but there is something which is fundamentally wrong inside our physical body, so which is in terms of the application, which is something which is wrong, or something which is not working fine inside your physical body. So same thing happens with the application as well. So fever or headache, or these are some of the symptoms. So when it comes to the performance application, these are the bottlenecks, something like the garbage collection issue, or the high response times, or less throughput. So what, as a performance tester, or what as a performance testing tool we use to find is, we are trying to find the symptoms, but we are not trying to fix it, or we are not trying to find what exact reason behind the reason for the bottleneck. So the performance engineering is something which will help you to fix the bottleneck. Like if you're getting a fever, so you're uh, trying to find what exactly is the reason behind that. Is that something due to any virus, or is that a bacterial fever, or is that a viral fever, or is that something related to uh, uh, any germs inside your body? So it's, I mean, like, you get a toothache or something, so you're just trying to break, or you're just trying to break, or you're just trying to fix the issue using your performance engineering knowledge. And now I know most of you must have come across a lot of performance testing, but people in the interview, or even when you join the organization, people might expect you to do the performance engineering role as well, right? If I'm not wrong. So there are, I mean, they're setting up the expectations more and more, because we all know, like, in the coming days, like, we were excelling in the performance testing, but in some scenarios people are expecting us to do the performance engineering tasks as well. So this video will definitely help you to understand the basics. I mean, like, I'll give you two different examples. So those two examples will help you to understand, or it will give you an idea, because if you go back tomorrow to the office, you will have some idea. Okay, so I learned something, so that I can fix something in the code which you faced as a performance bottleneck, right? So before we move on, so anybody has any doubt or something, any doubts or any queries before we move on to the first example? Or anybody want to say anything? Okay, I take that silence as no. And yeah, there's one more thing I just want to tell you. And I mean, I'm conducting a 2-day training on Load Runner, which is on 14th and 15th of September, where the main topic is going to be like using the Load Runner. We're going to do uh, API testing, SAP, and then the main one is the chatbot testing. So end-to-end chatbot testing will be performed in that training. So if you're interested, please do reach out to my WhatsApp channel, and you can get more details about that. And we are getting registrations as well. So thank you so much for that. And yeah, so now we'll go on to this performance engineering video, the first example. So here, the very basic example which I'm doing here is so again, this is something which you normally see in the application, but in a different way. Like you normally see it in a GUI format, but I'm trying to take the skeleton of it, like the exact way the how the code works in the application. So this code, so what it tells is I'm going to print a particular message like 1 million times, or like 1 million times. Like just imagine if you have like 1 million users who are using the system, and you are printing some message to them, right? So it's something like a get request, or it is something like a post request. So what happens is you might feel, or you might get a query from the customer telling that at this point of time, or like when I'm printing hello to the user, it's taking too much of time. So he asks you to fix it, or he asks you to find why exactly is it happening. So by doing a performance testing, you understood that this particular transaction takes too much of time. So now the next part is you have to find why is it taking too much of time. So let me first run this code for you, and I'll show you what exactly happens. So this is something like a performance response time. So since I'm running it with one user, I'm just showing it to you with 1 million users, and we'll try to emulate that scenario. So I have my code inside the, it's basically a C# code, which is a .NET code basically. And in fact, in our next videos, we'll try to solve it for the Java applications as well. But this is a very basic .NET application which runs on C#. And I have my file in the program.cs file. So I have a separate file here, and let me do it. Well, so before I run, I just do a build to make sure that there are no warnings, so there are no errors. And then let me do a quick run. So for that, I do .NET run. So when I start running it, so I'm printing the information, or just I'm printing the messages to the world, or just I'm printing these code of line in the applications in the GUI for the 1 million users who are visiting my website or my application. Right. So what happens is I'm continuously printing these code, which involves the disk input output, because I'm using the memory, I'm using the disk input output, I'm using the runtime, and I'm using the CPU as well, like the CPU of the app server. So basically, all these code sits on my app server, which is where the business logic sits in, right? So we all know the architecture. So we have the web server as the front end, or the presentation layer, and then we have the app server, which is where the business logic sits in, and then we have the database layer at the back end. So any request that we send in will go via the presentation layer, that is the web server, and it goes to the app server where the business logic sits in, and it works there. So for example, like if that particular request that we send does need only the logical thing, then it'll, or the business logic, that will take from this application layer. And if it still needs the data from the database layer, then it'll go back to the database. That's the backend database, and then it'll fetch the data, and then it'll print us. So in this scenario, I'm not involving any database layer, because this is something like a kind of a printing, or because not every request will need your database to print. So now if you see this single request, I'm just printing it. So this has actually taken around 85 seconds. So this amount of time is taken. And just imagine if you are running this in a peak server, and for like a huge amount of users, and with a high number of latency, which is like people will be accessing this particular request from different locations, from different places all across the globe. And just imagine how much time will it take, right? So what happens here? So I'll just tell you what are all the issues happened here, like this is something like observing, or this is something like you're trying to say that, see, these are the problems in your body, or these are the problems in your code that is making this particular code to run for 85 seconds. So what happens is, the first part is, we all know the very, very common issue, the memory allocation. So the first part is the garbage collection. So since we are frequently creating the string object, the string object here is the hello world, so the string object, right? And other internal objects for every console write, which is the hello world. So since we are printing it every single time, this will increase the load on the garbage collector. So we all know what is a garbage collector, which is clearing the old memory and giving space for the new memory. So since we are continuously printing and we are continuously giving more load, or we are keep on increasing the load, so this will lead to more frequent garbage collection cycle, because the moment a new object needs to get created, it does need to have some space in the hidden space. So for that, what it does is, it goes back to the old generation data, and then old generation memory, and it tries to clear it. But at the same time, it also has to create some space for the new data, or the new object that is getting created, right? So this actually involves too much of stress to the memory. So this, I mean, like, uh, more frequent garbage collection, right? So this will result in performance degradation, because the runtime will pass to clean up the unused objects, because rather than mainly the runtime, any application, like any code, it can be a Java, it can be .NET, it can be PHP. There is a runtime which actually takes care of running your code. So but in this scenario, when you're like keep on printing it, like too much of information to the GUI or to the front end, what happens is, mainly or basically, there will be a performance degradation will happen, because the runtime will take its most of its time to clean up the unused objects, rather than running the or rather than doing its actual work, right? So that's where the garbage collection so comes in. So we normally shout, like, okay, there's a garbage collection that's not happening properly, or that's a memory leak, which normally happens. So but the point is, okay, it's happy that it's good that you're finding the memory leaks, but you should also find why is it happening, which activity is the reason for this particular performance degradation. Okay, so that's what this performance engineering comes in. And then this console.writeLine hello world, right? So this will involve creating a new string object in memory, because this is like creating new objects, because when you're writing something, you're creating a new object, even though it appears like it is a string, each same string each time. So the .NET runtime typically use the identical values, because it does not eliminate the overhead, but still it will like keep on creating the strings, and it has to handle the output operation. So it involves too much of memory creation, it involves associating the strings creation, and also it also has to handle the output operation. So there are like multiple operations that is being handled by the memory. So that is the reason we say that there is a performance degradation, because of the garbage. I mean, the memory part is getting too much of stress, because it handles multiple work, right? So that is the main reason why we see memory leaks, or why the garbage collection is not working properly. And then the next part is the we normally see the disk input output, right? So this code here, it performs an input output operation every time, right? Whenever it prints a console.write line, so it is actually doing an input output operation, where you are getting some input and then you are printing it. So it's again, so input is something like you are giving this particular line as the input to the code, and that particular code gives you the hello world as the output. So this is the input output. So we normally see, while we do the performance monitoring, we see that there is a high amount of input output. What happens is, this is the input output that is normally happening. So there are like multiple other input output, but this, in this scenario, this exactly is the input output, because we are giving the system a command to print a line, and it is printing as a line for us. So what happens is, this message has to be converted to a byte stream, and then it has to be buffered, and then it has to be returned to the console output. So three continuous actions has to be continuously performed these many times. And since each message is printed individually, the program is continuously switching between the memory operation and the IO operation. Because why memory operation is, we have to clear the unused object, and then we have to create space for the new object. And then why the IO operations is, we have to uh, uh, get the input, which is the output. Sorry, the input is basically the console dot write line, and the output is the hello world. So we have to. We are. I mean, the system is actually continuously switching back and forth between the uh, memory operation and the IO operations. And again, the IO operations is also will get too much of stress because it has to convert the string to a byte stream. It has to do the buffering action, and then it has to write to the console output. So far we discussed about the high frequency of input output operations and the memory allocation. So you guys have any doubts with this part so far that we discussed? Any doubts, guys? If you have any memory mic problem, you can also message me in the chat. It's fine. I can read it from the chat box. Any questions, guys? Any queries? Or you're comfortable, you're okay. You can even give a thumbs up in the chat box if you're okay. It feels like I am the only one who is in the meeting. Thank you. Thanks. Thank you. Okay. So yeah, I take it as a I take it as a confirmation that you guys understand what I'm trying to what I'm saying so far. Okay, so just to give a overhead, so far we saw about two common issues and very frequently coming issues, which are the input output issue and then the memory issues. So how do we fix it, right? So that's the another thing. So when we are facing this issue during performance testing, and you have found out that there is some issue in this particular transaction or in this particular request, so now you have to fix it, right? So let me go back to the code which where I have fixed it, and then I'll run that code, and I'll show you. First I'll show you how does it work, and then I'll show you what has been fixed in that code. Yep. And here, okay, before running it, let me open the code. So I have my unoptimized app, and then I have my optimized app as well. So this here, I'm again doing the same part, which is I'm printing the hello world. But if you see in the previous the previous code where we did the execution, it has actually printed the same amount of number, but then it actually took 85 seconds. But then here, you see, if you see, we have got the same number of times to print the message, but I'll show you what will happen here if I'm running it in the optimized code. So let me run this. Previously, it took around 85 seconds to print the same amount, same number of message. But now in this optimized code, um, I think, yeah, this optimized code. Let's wait for a few more seconds, and yeah, by the time it prints, let me tell you information, because some of you have joined after the previous information. So what happens is like, okay, I'm conducting a load runner session, which is happening on September 14th and 15th. It's like 2-day session, and I'm covering about almost all the protocols like web, the API, uh, the SAP, and then the mobile, and even the chatbot testing. So there I will be discussing you, taking you through the end-to-end chatbot testing. So for someone who is interested to learn about chatbot testing, I mean the end-to-end, please do enroll to my session, and I will share you the link at the end of the session. And if you are someone who is in the WhatsApp channel, I think you must have known that. And if you haven't joined the WhatsApp channel, please do join the WhatsApp channel for any information. And we all have like around, I think, 400 people by now who can help you in any of your queries. And yeah, that's the information I wanted to tell you. Yeah, and now see, previously it took around 85 seconds, and now actually it took around 66 seconds. In fact, we were actually printing the same number of input output messages. But what is the difference here? I mean, why does it uh, printed very quickly? Is okay. So in this code, what we introduced is we were optimizing the loop by using the batching. So when we do batching, what happens is we are printing the messages batch by batch, and even we can even control the number of batches as well. So here, if you see, I'm controlling the batch by around like 10,000. So which means if I have like around 10 million, like 1 million number of print that I have to print. So what I do is I collect the first set of messages which I have to print, and then I print it. I give the space to memory, and then the memory, what does it does? It clears the old batch, and then it gives space for the new batch, and then the new batch comes in. So what happens here is the memory will not be involved all the time for printing the message. Instead, it takes our, in fact, like like I told you in the previous one, like what happens while we are printing the continuous messages. So what happens is like while you are printing continuous messages, your output operations or your runtime, everything will be completely occupied. But when you're doing it via batch sizes, so this is one of the way where you can optimize the code or where you can optimize the loop. So when you're doing it through this way, your memory will get enough amount of space. You have enough amount of time for garbage collection. Your runtime will have its own time for clearing the garbage and for also printing the messages, for doing all the runtime actions. So by doing this method or by doing this way, you can fix this issue. And in fact, this is one of the way which we can fix it. And there are like several other options, like you can do it via batching, you can do it via optimizing the loop, and you can even limit the amount of printing messages, and you can even distribute the printing message. So there are like several ways, but this is one of the proven method where I have used in one of the scenarios where there were like a scenario where we were about to print too much of information. Like this, in this scenario I'm just printing hello world, but in that scenario I'm just printing a huge amount of message. I'm just sending emails, I'm just printing the messages to a huge set of stakeholders. So in that scenario again, this same thing happens because the app layer has taken too much of effort to print all those messages. So by using this efficient optimization method, what did I do is I have introduced the batch size where I'll be printing the messages in batch format. So every single batch will be printed, and then the memory will not be like completely occupied. So I just give, or I just avoided the way where I don't want to overlook the memory or the garbage collection part. So this is one of the method where I have used to solve this issue. And if I let me just go through the code. So what I do is I am creating an object which is for the batch size, and then I'm going to print the entire message, but for every batch. So this code will run for every batch, and then after every batch there will be it will print the messages, and then once it is printed, if there are any messages, it will be again printed. So until it completely prints out all the messages, it won't come out of the loop, but it will print on the batch sizes. It will print on the, for every batch it will print, and then it will come to the next iteration, and then it will do the batch the printing. So by doing this way, I have reduced the overload, I have reduced the number of input output operations, and also it know what exactly it has to do, because the input output operation will happen the first time, and then after that there will be a delay where the memory part will be taken care, and then again the second set of input output operation will happen. So this way I have optimized the issue. I have optimized the issue, the code, and then I have fixed the issue. So any doubts guys so far? Shall we proceed to the next example now? Yeah, you can even print in the chat window, or you can even give a thumbs up. I will take it as a S. Yeah, thank you. Okay, fine. So let's go to the next example now. Thank you. Thanks for the confirmation. So the next one is okay. So this is again something which I have so far explained you is in terms of the code, right? So in terms of the code, you must be able to fix it. And the second part is the very common one, which is we get via the database. So even in the database also, what happens is like if we are using any unoptimized query, what happens is it will take too much of time for printing or for getting some data. So for example, take for an example, if you're going to Amazon.com, and if you're searching for some items, right? So if you're searching for a laptop, or if you're searching for mouse, or if you're searching for a hard disk, whatever it is. So the moment you search, automatically you start to get the message, right? But just imagine if it is, what will you do if it is taking too much of time? So we again never go back to that application, because the moment it takes like more than 3 seconds to 5 seconds, we'll get frustrated. Again, that's what the international study has also has confirmed. Like if some page is taking like more than 3 seconds or 5 seconds, people never use that particular page again. Like anything, like it can be a Amazon, like an e-retail application, or it can be even a ticket booking application, or whatever the application is. So that's, I mean, people are completely impatient, because we currently are using the highest amount of speed of network, but still people are not ready to wait for even 1 second. And that's what the application owners are also concerned about. So they want to give you the application in a very quick manner, so people will continuously keep on using your application, right? So let me, okay, so in this scenario, sorry. So in this scenario, what I'm showing you is, or what I'm going to trying to show you is, I'm going to extract some data from the database through the .NET code. So this again is something similar to any of our applications. So if you're someone who is using in a retail application, or if you're someone who is in a banking application, so you, at any point of time, you are going to query some data, and then you are going to print it to the application front end, to the presentation layer. So in this scenario, so in the previous scenario, we did connected only the presentation layer and the application layer, where we had the business logic. So in this scenario, we are connecting the presentation layer. We are sending some request, and then it goes to the application layer, and then it turns in turn it goes to the database layer, where we are going to fetch the data from the database. So I have my code here. So let me just open and show you the code. So here I have my code where I'm going to fetch some data from my database. I'm using MySQL database, and I'm fetching some data, and I'll show you what happens when I'm fetching my data and show you. And I have two queries. One is the unoptimized, and then one is the optimized one. Just don't worry about the code which you are seeing here. Just look at only the query here. So the query is the important one, because whatever you see the .NET code here, it's just to print, or it's just to print whatever data that we collect from the query. So again, I will show you there is another quick catch, because there are two things. One is I have taken the time for calculating the query, and then I have taken the time for printing that as well. So there are like too many informations. Like once you start involving it, once you start learning this, you'll get to know lots and lots of information about the performance engineering and how to fix those issues. And I really appreciate you keep on looking for these kind of trainings for you. And yeah, so here I have my database, and I have several tables as well. And so mainly this database is about actor, actress, address, category, city, country, customer. So what I'm going to do is I'm going to just fetch few data from this database, and then I'm going to print it to the application. So I'm using Visual Code, where I have set up my .NET code in it. So firstly, let me go to the, okay, yeah. So I'm into my unoptimized query, the very first example which I'm going to show you. And let me do a quick build. Then I'm going to run this query. And before I run this, let me just take you through the code. So yeah, if you can see here, the time it took to execute the query is around 1.76 seconds, and the total elapsed time is around like 2.14 seconds. So just imagine I'm just having around like I believe like around like 10,000 number of data, and just imagine how much amount of data you have in your databases. Like it will be like more than 10 million to 20 million amount of data, and your query has to parse through the entire set of databases, right? So it has to go through starting from the starting data to the end data, based on the joins that you are doing, and then based on the where query, and then based on the group by, and then finally you are say using your having count, and then you're going to order it at the end through the total rental. So in this scenario, what I'm doing is I'm going to select these values, that is the actor ID, the first name, his last name, and then the title of the film, and then the description, and then the category name. So for example, let me just show you one of the examples. So here I have the actor ID 150 and his name, his last name, and then the film title, and then I have the film description, the documentary of a car. I think someone has joined now. Let me add him. Yep. And then I have the category of this movie, and then the total rentals, how many times the movie was rented, and then the average days since it was released, and then the time. Okay, and then so this is one particular set of data which I was printing. So just imagine you are querying something in your databases, in your just imagine like it can be an amazon.com, or you're just printing your querying, you're searching some item, you want to order some food for the party, so you're going to Pizza Hut or any of the website and you're searching for some pizza, so it will print you lots and lots of information for you, and at the same time it's also printing the same set of information or a different information to another thousands of users or another lakhs or another millions of users at the same time. So this is happening in two different users, but the action is same. Just going to search from the same database with different queries. So that'll be like more overhead comparing to this single machine. So just imagine if it is showing like 1.7 seconds to execute for one particular user, just imagine how much time it will take for every user, and just imagine how much time it takes for the latency and everything. So it will be more than what you actually see. So our uh, task as a performance tester and as a performance engineer is to observe what is going wrong, and then our next task is to fix it, right? So in this scenario we're going to fix this particular query. So I'm selecting all these data. When I'm joining the tables with different tables, like I'm joining the film actor FA on actor ID, like I'm using the join for connecting the actor ID from the actions table to the FA. So I think the FA is the film actor table, and then same with the film ID, and then same way I'm connecting all the tables, and then finally I'm adding a condition where the movie's release year has to be between 1990 and 2020. So any movie that's released between this year, and then I'm going to group them by actor ID, and then the first name, last name, title, description, and name. And also, I'm going to have a count. So if it is like more than 10, if the rental ID is more than 10, the count of the rental ID is more than 10, then I'm going to print those details ordered by desk. DESC is actually descending order. So basically, we have two orders. One is the ascending order, and then the other one is the descending order. So in this scenario, I'm going to print them through the descending order. So I can even take you to the first. I think most of the dates are like same. So since release, so you can see only the same dates. The since release is going to be the same one everywhere. So that's what I'm going to print. So now, like I showed you, it nearly took 1.76 seconds for executing this query, and then it nearly took 2.14 seconds to print it. So in this scenario, like I told you, we're going to fix only the query part, right? So any doubts so far, guys? Yeah, please go. Yeah, Shibin. Okay, okay. You're giving thumbs up. Fine, got it. Okay, so I understand that you guys are okay. I mean, like you guys understood what I'm explaining you so far. So now let me go back to the optimized query. So I'll again show you what is fixed, or how did I fix this query. So going back to the database folder, and then let me run the same one. So before that, let me show you the code. So here, again, I'm printing the same set of data. So there are like two methods which I have used to fix this. So it's the same set of data which I'm using to print the value. And let me run this code first. So yeah, so previously, let me just show you the previous one. So in the previous, the first example, the non-optimized one, where you can see it took nearly 1.76 seconds. But here in this scenario, it is showing it is actually taking zero point 0.5 seconds to print the value. So what is the difference? Like how uh, the response time has come down. So the thing that has changed here is I have limited the first thing, the first method of fixing this issue is I'm limiting the number of information which I want to print to the users. So this is what actually happens when you open a Amazon.website, Amazon.com, right? So when you search for something, it will print you only the very first few items rather than printing the entire set of data. When you want to search for mouse or a keyboard, you know that Amazon almost has like around 6,000 to 10,000 dealers or 6,000 to 10,000 products in it. But do you think it actually prints you everything? No, it actually limits, it actually prints you only the first 20 items or first 10 items. So that is the way you get to understand, okay, the application is very quicker, but actually it will take a long time if it really wants to print the entire set of data. But instead what it does is it actually prints you only the limited amount of data. So the moment you want to take only the first few set of data, you will be very happy that okay, the data has come very quick, and you will start to see the first few information. And mean at the meantime, the next set of data will be queried. And when you click on like the page two, so what will happen is like the second set of 100 data or the second set of 20 data will be queried. So by doing this way, what happens is the first thing is it creates an illusion that the application works perfectly fine, or that is very less response time, or the application works fine. Yes, that's true in some scenario, because you are limiting the amount of data that you want to print it to the user. So one thing is you are not giving too much of overload to the system, and you are just printing only the required information for the user. So I mean, again, the user, in terms of the user. So as a user, you will see that you'll take some time to just go through the first 20 items, because you are not, even if the system is able to give you all the 6,000 products or 6,000 items, you will not be in a situation to go through everything. So you will just go through the first page where you have like 10 items or 20 items, and then you'll go to the second page. So by the time you click on the second page, you know that it's going to be the second set of data. You're going to get the data from the 21 to 40. So that's the way you as a performance tester, you as a performance engineer has to decide, or you have to plan, or you have to come up with a solution. So this is again one of the method. I mean, like even I have like two methods. There are like lots and lots of other methods, but if you're okay, you can also use this method. You can give this as a recommendation. But I know performance testers might not have access to the code, but still, if you really want to improve your performance engineering skills, or if you give these examples in the interviews, right, so they'll be impressed, because that's again the main thing. Because the moment you most of us has a problem, because we know how to work, but the problem is most of us has a problem in clearing the interview. So these are some of the scenarios where if someone asks you, did you have an real-time example where you have solved this issue? Yep, you can honestly, you can explain this scenario with, you can just take a paper, you can just write it and show it to him. So this is how I have fixed this issue. He'll be very happy and create a very good impression. So these are some of the ways where you can clear your interviews. And in fact, I would say that this is one of the example which one of our subscriber has used in the previous interviews, and he has got cleared it. So you can very well use it. So no harm in it. So yeah, I think you must have understand what I'm trying to explain you. So what I did is I'm querying the same set of data. I'm using the same query, but I'm limiting the amount of data which I want to show it to the user. So this way, what I do is I have reduced the overload to the query, but I was able to also get the amount of data which I want to get it very soon, and then I'm printing it, and then I'm going to the next page. So this is one method. So now I'll take you to the second method. Before that, let me just comment it. Yep, I have commented it. And then the second method. So this is the second method which I have used to fix this issue. So let me run this, and then I'll tell you what did I do here. And let me just save it. And since I have made a change to the code, let me do a quick build to make sure there are no syntax errors or there are no any other errors in the code. So yep, looks fine. The build is succeeded, 0 warnings and 0 errors. Let me run the query now. So in the previous scenario, so you saw it took around like zero point 0.5 seconds, and now in this one, it even took lesser than that. Even though I have limited to 1,000, still the time to execute the query is like zero point 0.3. So just imagine we have reduced the amount of response time from 1.7 to zero point 0.3. So this is what exactly any organization or any business owner needs us to do, right? So they want us to reduce the response time. So just imagine the way we have improved the performance of the application. So okay, before that, let me show you what did I do. So here I made a few change in the code. So what did I do is, instead of giving the join in this code, what I do is I'm creating a subquery. So this will actually take care of the rental part, where it will do the left join, and it will take the inventory ID between the tables. It will group it based on the film ID, and then that particular data will be passed into the main query, and that will be accessed, and then I'm getting the actual data. So what I do is, so in this scenario, so in the first method, I have limited the amount of data, but in the second scenario, where if the user does says, no, this scenario is completely different, where I want to print the entire amount of data. So in this scenario, you can use a subquery to pre-aggregate the rentals. So in this scenario, I'm pre-aggregating the rentals. So what happens here is, every time before I go to the main query, I just go to the subquery, do the processing, and then I go to the main query. Automatically what happens is the runtime will be reduced in a huge way. Like, just imagine, even in this previous example, I have limited to 100, but it still took like zero point 0.5 seconds. But in this scenario, even though I have used the limit to 1,000, but still I was able to crack it in under less than zero point 0.3 seconds. So using subquery is another solution for this particular way. Like, if your query takes too much of time for querying, I mean, like most of the times, like I would say like 60 to 70% of time, what we do is, like, we used to query data from the databases. Like, we used to read information from the databases rather than posting it. So most of these are like GET requests. So if you find some GET requests are taking too much of time, so this could be the reason. You just have to get an access to the code, try to understand like what exactly is happening in the databases, try to give and explain to the code and see what exactly is the databases is doing, and try to understand how does it work, right? So I think I have explained the both examples in this scenario. And you guys have any doubts or any queries, guys? I mean, like, this is the only thing which I wanted to explain you. And in fact, like, going forward, I'm planning to have a 1 day training on the performance engineering, where I will take you through several examples like this. Like, there are like algorithm optimization, where we know the algorithmic approach, the bubbles, we must have studied in our college days, like the bubble sort and different ways of sorting. So even that is being used in the code, where we are going to sort the data in different manner. So I'll be explaining you those algorithmic optimization value, and there are like several other opportunities for you to fix your database issues. Like, this subquery is one of the way, or limiting the amount of data is another way. And there are like other options, like where you can use the stored procedures, and there are like several other options where you can create indexes. That's another way. Like, the business or the database owners, the administrators might have told you, they might have discussed about the database indexes, right? Where they say that I have created some indexes, but still the performance has not improved. Or they might say that, they might tell you that I have created indexes, and that has bring down the response time. But again, indexes is a kind of a temporary fix, because most of the times the amount of the data query might be changing it. So every time they have to keep on changing the indexes, or they have to keep on adding the indexes. So there are like several other drawbacks as well in terms of indexes, and there are like other ways of doing the caching as well. So when you introduce more of amount of a caching, so that also will help you to bring the amount of workload to the databases. Instead, it will take it from the cache. So there are like several other options, like to improve the performance of the application. So these are like some of the ways where we can improve the performance of the application. Okay. So yeah, I think I have taken you through the examples which I wanted to tell you today. Yeah, like I told you, if you are interested for performance engineering 1 day session, I will. It won't be like this. I will give you the code, and you can actually demo. You can actually try it from your machine, if you have a Visual Studio Code installed in the machine. And someday we can try for one particular day, and you will understand too much of like every information. And again, it will help you for your performance engineering knowledge, and it also will help you to crack your interviews as well, because like I told you, nowadays the benchmark is not just performance testing. The benchmark has been increased or improved to the performance engineering. So I'm just trying to help you to get a good career. So that's it. And yeah, anybody have any doubt, you can just message me in the chat box. And if you find the session is useful, you can also write your feedback. You can give me your comments in the YouTube channel, and you can also add your comments in the WhatsApp channel as well. So any doubts, guys? Or if everybody is okay, then I think we are done for the day. And yeah, before I close this session, just another same information. Like we are having our load runner 2-day trainings. 2-day training. It will be going mostly. It will be like a boot camp where it'll be like a one-on-one kind of a session where I will go through everybody mission, and then we'll have a it's kind of a hands-on for the 2 entire days, and then we'll see how to do all the basics, basic part like parameterization, correlation, manual parameterization, manual correlation, and then like I told you, the chatbot uh, testing, end-to-end testing. I know most of the clients are asking for chatbot performance testing, so we'll just go through it. And yeah, that's happening on September 14th and 15th. So if you're interested, please do enroll it for the training session. And then yeah, that's it for me. And if you have anything to say, please you can chat in the chat box, or else you can take a leave, and then we'll meet in our next boot camp. Sometime I'm planning for a GitHub session or Git session. Before that's part of the SRE. So for those who are interested to develop your knowledge in SRE, the Service Reliability Engineering rule, you can enjoy very well enroll to the session. And yep, with that I come to an end, and we'll meet in the next session. Yep. Thank you and so much. Thank you so much for joining the session. Thanks so much for your time, and yeah, see you in my next bootcamp and session. Thank you. Bye bye.
Thank you.
Thank you. Bye.